In this video, we will use Desmos in order to create a scatter plot and perform quadratic regression. The table below shows the height h in meters of an object that is thrown off the top of a building t seconds after it is thrown. Make a scatter plot of the data, then use regression to find a quadratic equation that best fits the data. Write the equation in the form y equals ax squared plus bx plus c. Round a, b, and c to the hundredths place value. In our case, though, we'll be using the variables of h and t rather than y and x. The first step is enter the data in Desmos, and there are a couple of ways of doing this. We first go to desmos.com and click Start Graphing. To enter the data manually, we click plus for add and then add a table. We enter the times under x sub 1 and the heights under y sub 1. However, if we have the data in a spreadsheet, we can simply copy and paste the entire table in one step. Let's go ahead and do this. I'm going to go ahead and close this table. And again, assuming the data is in a spreadsheet, for example, here I have the data in Excel, we highlight the columns, press Ctrl+C for copy, go back to Desmos, click in cell 1, and then paste the table by pressing Ctrl+V. Notice when we do this, we have the entire table in one step, and we have the graph of the scatter plot on the right. The advantage of doing this is the window is automatically adjusted. However, in this case, notice how we do not see the horizontal axis, which I would like to see. So let's go ahead and adjust the window by clicking the wrench, going down to the y-axis, and changing the interval to -20 to 120. Notice now we can see the horizontal axis. Let's close this by clicking the wrench. Let's also reposition the graph slightly by holding and dragging it. And now we can perform our regression. Notice how the variables are x sub 1 and y sub 1. We must use these variables when performing quadratic regression. Go back up to the plus for add and add a function / expression. We need to begin by entering y sub 1, which we can do from a keyboard or from the Desmos keyboard. I will use the Desmos keyboard so you can see what I'm pressing. So I press Show Keyboard and enter y1 for y sub 1. When performing regression, we do not use the equal sign. We use the twiddle or tilde, which means regressed against. To access the tilde, press the letter keyboard button, and the tilde is here in the lower right-hand corner. And now we need to enter a times x sub 1 squared plus b times x sub 1 plus c. So let's enter a, and then x, go back to the number keypad, 1, which gives us x sub 1, raised to the second power, so we press the a squared button, plus, go back to the letter keypad, press bx. We need to enter 1 for x sub 1. Go back to the number keypad, press 1, and then plus. Go back to the letters and press C. Notice once we finish this, we have the approximate values for A, B, and C for the quadratic model. If we close the keyboard, notice how we also have the graph of the quadratic model on top of the scatter plot. Notice how r squared is very close to 1, which means we do have a very good model. We are told to round a, b, and c to 2 decimal places. Remember, we are using the variables h and t, so our rounded regression model is going to be h equals -5.97 t squared plus 35.31 t plus 46.5. Let's record this. And now we'll go ahead and use the graph in Desmos to answer some questions. Next, we're asked to predict the height of the object after 6 seconds, round to the tenths. So going back to Desmos, we will answer this question graphically. Let's click the plus and then add a function or expression. And let's go ahead and enter the equation x equals 6. This is a vertical line which we can't see because we need to adjust the window. To adjust the window, we can click the minus to zoom out, or we could also adjust the window manually by clicking on the wrench. but this looks pretty good. Let's leave this, but let's also reposition the graph by holding and dragging it. If we find the point of intersection of the vertical line x equals 6 and the graph of the quadratic model, we can determine the approximate height at 6 seconds. Clicking the intersection point here, notice how the ordered pair appears. We have 6, 43.371. We're told to round the height to 1 decimal place, and therefore the height is approximately 43.4 meters at the time of 6 seconds. Let's record this. So we'll say the height is approximately 43.4 meters, again after 6 seconds. Next, we're asked to predict the time to the nearest tenth of a second when the object is at a height of 70 meters. So again, going back to our graph, let's click plus, add another function or expression, and enter y equals 70. Notice how this gives us the red horizontal line, and notice how this line intersects the graph in 2 places, and therefore there are 2 times in which the height is 70 feet. Let's click the 2 points of intersection, here and here. Notice how the height is 70 at approximately 0.8 seconds, as well as approximately 5.1 seconds. And again, let's go ahead and record this. And lastly, we're asked to predict the time to the nearest tenth of a second when the object hits the ground. The object hits the ground when the height is equal to 0. So again, going back to the graph, we know time has to be positive, and therefore there's only one time when the object hits the ground, or when the height is 0. That's at this point here. If we click on this point, notice how we have 7.022, 0, which means at approximately 7.0 seconds, the object hits the ground. We do not use this horizontal intercept here on the left because notice how the time is negative and time cannot be negative. So the object hits the ground at approximately 7.0 seconds. Now there is one thing I do want to mention. When we answer these questions, we did use the graph based upon these values of A, B, and C. If we use the rounded values that we entered for our equation in the first part, it would give us slightly different answers, but our answers would have more accuracy because the values of A, B, and C have more decimal places. I hope you found this helpful.